Hello everyone, this video is about forms of complex numbers and principal argument. Usually we say that the square root of -4 doesn't exist. Well, actually, in the real world, the square root of -4 is undefined, but in the complex world, the square root of -4 is actually 2i, which is well defined. So in your calculator, you can use this mode, complex mode, if you have the function. And if you try the square root of -9 now, you'll get 3i, and I squared is -1. And you can also do multiplications or additions using I. You just press shift and there's an I somewhere in your calculator. You can only do this to check or verify your answer, but you have to show the complete working in the exam. So I is the square root of -1, and therefore the square root of -9 is the square root of -1 times 9, which is I times 3. And the square root of -7 is I times root 7. I squared is I times I, which is -1. I cubed is I squared times I, which is -1 times I to the fourth is I cubed times I cubed is minus I, so minus I times I, which is minus times -1, which is 1. So as you can see, we have the pattern I -1 minus I and back to 1. So I to the 100th power is therefore, if it's a multiple of 4, it's gonna go back to 1. Now this form z equals a plus bi is called the Cartesian form. For example, 3 plus 4i. The 3 is the real part, the 4 is the imaginary part. We use this symbol REIM. Complex numbers means we have a real and an imaginary numbers combined. This is called an Argand diagram, just like Cartesian diagram, but the axes are real and imaginary axes. For the example 3 plus 4i, we get this kind of line, and we can find the modulus or the magnitude or the length using Pythagoras. So the r or the modulus of z is the square root of the components, and theta or the argument, the angle, is inverse tangent the imaginary divided by the real part, or y over x usually. The principal argument, this is a convention between minus pi and pi, so we don't use 0 to 2 pi. If we use polar form, so as you can see, the length or the hypotenuse is 5, and the angle here, let's say theta. The height or the y value or the imaginary part is 5 sine theta, and the real part is 5 cos theta. Just use trigonometry. So therefore we can express the same complex number using 5 cos theta plus I times 5 sine theta. Cos plus I sine can be shortened into cis, so 5 cis theta. This is called the polar form. This is the general form, and we can also use something called the exponential form. Cis theta is equal to e to the I theta. If you want to know why, just see the formula derivation PDF or video. And this is the general form. We have the modulus and the argument like this. If you want to convert from Cartesian to other forms, we use Pythagoras to find the modulus, and we use inverse tangent to find the argument, and we can use cos plus I sine or cis. In exponential, just use the argument, the modulus and the argument like this. And from polar to Cartesian, we just use the modulus times cos argument plus I times modulus sine argument. To find the exponential, just read the modulus and the argument. From exponential, you can convert to polar simply by using the cis here, and convert to Cartesian again using cos and sine. And now here in these examples, we always use the first quadrant complex numbers. Both real parts and imaginary parts are positive. What if we have negative parts, imaginary or real? So the angle calculation is the same as usual. We use positive x in this direction for positive, and from positive x in this direction, clockwise direction, for negative angle. Same naming for the quadrants: Q1, quadrant 1, 2, 3, 4. To find the angle in the first quadrant, just use inverse tangent. Fourth quadrant, also inverse tangent. But for the second quadrant, we use inverse tangent plus pi, because from the inverse tangent you will get something negative. And for the third quadrant, inverse tangent minus pi, because from the inverse tangent you will get something positive. If we have positive, which is in the first quadrant, we just use inverse tangent. Negative, positive, of course this is in the second quadrant, we use inverse tangent. We include the negative, as you can see, we include the negative in this -2 plus pi. And for negative, again we include the negative in the inverse tangent calculation. And for the fourth quadrant, just inverse tangent. Here's some examples. You can just try first on your own, maybe pause the video. And the solution is this. Alright, I'll see you again next time.